And welcome back to our second video, ladies and gentlemen. We're talking similar triangles, and now we're using indirect measurement. You took some notes from page 129 or 553 respectively, and all you wrote down to say, hey, indirect measurement, just a method of finding a measurement using similar figures and corresponding sides for a measurement that's not very easy to make directly. That's why it's called indirect. So we can use that to estimate some lengths and some other values. So, ladies and gentlemen, let's do a quick review of similar figures. Similar figures being what? The same shape. That's right. They also have congruent angles. And then they have corresponding sides that are proportional. So, we can use that, proving that these triangles or these figures are similar, using the angles, and then saying that the sides are proportional and using those proportional sides to help us find the missing measure that we don't know how to do directly, or that we can't do very easily directly. So one of the methods that we're going to talk about is the mirror method. Mirror method right here says, hey, I can put a mirror on the ground, and then I can move myself to a position where my eyesight hitting the mirror and then sees the very top of whatever object it is I want to measure. Because what can we then do that we can figure out? That's right, we can measure from the mirror to ourselves. We know that one. We can measure from the bottom of ourselves to the top of ourselves. We know that one. And we can measure from that mirror all the way to the center of the object that we want. We know that one. And so now that we have these sides, we can do this. But you're probably saying, well, wait a minute. How do I know those triangles are similar? Well, let's think about this. I can draw a line from the top of that object straight down, and I get a right angle there. The top of our head straight down, I get a right angle there. And then I have, that's one congruent angle. We need two of them. We just learned how to do this. I can make these in vertical angles. So this vertical angle here and this vertical angle here by drawing the extension of those sights, and then say, hey, the ground actually bisects or cuts those angles directly in half, therefore saying that this angle right here is going to be the same as that angle right there. Now we have two congruent angles, the third one's congruent, voila, we have similar figures, and we can use our proportional reasoning to find an indirect measurement. The other measure we're going to talk about is called shadow reckoning. Hello, shadow created from the sun. And so we can take our object, we can draw straight down, that creates a right angle. The shadow goes down somewhere on the ground, we can measure that. And so we have this angle here. And then we can take our height and we can move ourselves in that shadow until we start to see it. And we can say, hey, we have our height, that's a right angle, so that's one angle. And then of course, because it shoots down here, it's going to create that same congruent angle. Now we have two congruent angles, so we have similar figures. We can measure our height, we can measure our shadow, we can measure the shadow of the object. Hence, we can find and estimate the height of the object. Shadow reckoning. And so, moving forward, let's practice real quick with two different examples on just writing proportions so that we can solve for a missing side length. It says they're similar, so we know they're the same shape. We know that the angles are congruent, and we know that the sides are proportional. It says write a proportion. Okay, so I'm going to write my proportion template right there. And I know that for the larger, and you know me, I like to start with x. I'm going to go x over 12, and I like to stay with that figure. And then I've got to go to the second figure. And what side corresponds to x? Well, that's right, 10 does. So we're going to go 10 to 6 on our second ratio. And then we're going to do our cross products. And we're going to say that 120 is equal to 6x. We're going to divide by 6. And we're going to say that x is equal to 20. Very good. Our next one, a little bit more challenging, but again, a nice review. Says, hey, these two figures are similar. We know that because of the similarity statement. Find SU. So I'm going to do that right here. I'm going to use red to find SU. That's this side. Not SU, I'm sorry, SV. SV, that's that side right here. So I'm going to go X2, and then of course 21, because that's on the same figure. That's how I like to do it. You know, we can write many proportions that will work. Is equal to, well, the corresponding side to X, figuring out the transformation and that the orientation is different, I recognize that being 20. And then, of course, I'm going to do that to the corresponding side to 21, which is 35. So when I do this, I get 420 is equal to 35x. Dividing by 35, I get that x is equal to 12. So I know this side is 12. Well, if I take another close look, because these figures are similar and the sides are proportional, I notice that this side 20, which corresponds to this side 12, is also the same length as this side over here. So when I do UV right here, I know it has to be the same as this other one, so that has to be 12. So both SV and UV are 12. So I don't need to write the proportions. If you want to, you can prove it. I don't mind. And then I'm going to do the last one, TU, which is this side right here. I'm going to call that X with my blue. And I'm going to again do that one to side 21. The corresponding side to X would be right here, which is 25. And the corresponding side to 21 again is 35. So now when I do my cross products, 21 times 25 is 525, and that equals 35x. When I divide by 35, I get that x is equal to 15. So that means that side is 15. All right, so we practiced that a little bit, and that should have been just a review. Let's go on to using some of this indirect measurement. And our first example says you plan to cross the river and you want to know how far it is to the other side. You take measurements on your side of the river and make the drawing shown. First, explain why triangle ABC and DEC are similar. Well, let's go back to what we learned a video or so ago. First of all, we have a right angle in ABC and DEC. And so we know that angle, B, is congruent to angle E. So that's one angle, it's congruent. And then we see that we have, right here, I'm going to draw on it with black, we have these two vertical angles right here. So we know that angle C is congruent to angle C. On both sides, we're just going to call it C, the opposite angles that are vertical formed by two intersecting lines. So now we have similar figures or similar triangles because two angles are congruent. We know the third one is, we know we have similar figures. So then we have to find what the distance across the river X is. So of course, we know that we have similar figures. That means the sides are proportional. So I write my proportion template, and then I come over here. I want to know what X is. You know me. I always put that first, and I always stay with the same figure. So I'm putting that over 30. You can do it any way you want. My way is not the only way. And then, of course, I've got to figure out, in triangle ABC, what side corresponds to side DE, where that distance X is that we want to know. And, of course, if I rotate it and do all these other things, I find that that is side 50. So that's got to go on top, and that would go to 40 right here. And then when I do cross products, I would get that 50 times 30 is 1,500 is equal to 40x. When I divide by 40, I get that x is equal to 37.5 feet across that river. Very good. Again, pause and write, and then continue on with our next example, which is right here. You can use indirect measurement to estimate the height of the flagpole. First, measure your distance from the base of the flagpole and the distance from the ground to a point on the flagpole that you are looking at. Maintaining the same angle of sight. Move back until the top of the flagpole is in your line of sight. A, explain why triangle ABC and DBE are similar. So, let's highlight that. First of all, angle ABC, that's this one right here. I'm highlighting it in red. All right. And then I have triangle DBE, which is going to be the blue one. Well, we already know that angle B, it's the same. It's the center of both of those. So angle B is congruent to angle B. So we have one angle that's congruent. And then the key words in the story problem, is maintaining the same angle of sight. which means this angle of sight here and this angle of sight here, if it maintains the same angle, then those angles are congruent. So angle A is congruent to angle D. Now we have two angles that are congruent, so the figures are similar. All right. So now we've proven these are similar. We know when they're similar, we can make a proportion to find these missing side lengths. So I'm going to make a proportion. I'm going to use a proportion template. So now I've got to find the information to fill it in. I'm going to use those same triangles. So I need to find, in my triangle ABC, the red one, this length right here. Right here. And it says from the ground to the height of that angle of sight is 7.5, but I'm standing 4.5 feet. So if I take 7.5 and subtract the 4.5, that side length right there is 3 feet. So I'm going to put 3 feet right here. And it's not my X, but I'm starting with that one. I know that the distance of side AB right here is where I'm standing to the flagpole, and that is 5 feet. So I have 3 to 5 is equal to. I also know that after I move backwards to see the top of the flagpole, that real entire length is 22. And of course, I don't know how tall it is from here to my line of sight the second time. But I can do cross products, and I get 66 is equal to 5x. When I divide by 5, I get x is equal to, well, that's 13 1/5, which is 13.2 feet. But that's not the height of the flagpole. That's only the height of that triangle. We have to add in the 4.5 feet that we are standing to the ground. So plus 4.5 gives us 17.7 feet. Well, 0.7 feet is roughly 8 point something inches. So 17 feet, 4 inches is roughly how tall that flagpole is. Again, estimate. We're estimating, so it's pretty dang darn good. Ladies and gentlemen, that ends this video. You have a quick write. You're going to need to make a rough drawing of this and label it. Then come to class, and it will help us discuss more and answer more questions to help you understand using similar figures and indirect measurement to find measurements that are difficult to do directly. I look forward to seeing you and listening to your questions and answering them tomorrow. Good night, ladies and gentlemen.